We all know plastic is everywhere. It's in our oceans, our landfills, and even our food. The convenience of plastic has led to its ubiquitous presence in our daily lives. But this convenience comes at a significant cost to our environment and health. But did you know that we're also breathing in tiny plastic particles called microplastics? These particles are so small that they can easily become airborne and enter our respiratory system without us even realizing it. These microscopic fragments are less than 5 millimeters in diameter, often originating from the breakdown of larger plastic items or being manufactured at that size for use in various products. To put it in perspective, they are smaller than a sesame seed, making them nearly impossible to detect with the naked eye, and are practically invisible to the naked eye. This invisibility makes them even more insidious, as we cannot see the threat we are inhaling with every breath. They come from larger plastic products that break down over time, such as bottles, bags, and other everyday items that degrade into smaller and smaller pieces. But they can also be manufactured at that size. Microbeads in cosmetics and industrial abrasives are examples of intentionally produced microplastics. While we've known about microplastics in our water and food for some time now, the realization that they are also present in the air we breathe adds a new dimension to the problem. Researchers are sounding the alarm about airborne microplastics and their potential impact on our health. The presence of these particles in the air means that they can be inhaled directly into our lungs. You might be surprised to learn that microplastics have been found in human lung tissue, where they can cause physical damage and inflammation, blood, and even placentas. This indicates that microplastics can travel throughout our bodies, potentially affecting multiple organs and systems. This means these tiny particles are small enough to bypass our body's natural defenses and travel throughout our system. Once inside, they can lodge in tissues and organs, leading to various health issues. Scientists are still working to understand the full extent of the dangers these particles pose, but the preliminary findings are alarming. But early research suggests they have the potential to trigger inflammation, damage cells, and disrupt hormone function. These effects could lead to chronic health conditions over time. While more research is needed to fully understand the long-term consequences of breathing in microplastics, the urgency to address this issue is clear. The evidence so far is concerning. The potential for widespread health impacts means that we cannot afford to ignore this issue. The fact that these particles are so pervasive in our environment and can easily enter our bodies means we need to pay close attention to this emerging health threat. Taking steps to reduce our exposure is crucial. In the following sections, we'll delve deeper into the sources of airborne microplastics, exploring how they enter the air and the various ways they can be inhaled, their specific effects on different bodily systems, including the respiratory, cardiovascular, and endocrine systems, and what we can do to protect ourselves. From using air purifiers to advocating for stricter regulations on plastic production, there are steps we can take to mitigate this invisible threat. You might be wondering how these tiny particles end up floating in the air we breathe. It's a question that has puzzled scientists and environmentalists alike, as the presence of microplastics in the atmosphere poses significant risks to both human health and the environment. The answer is that microplastics can become airborne through a variety of human activities. These activities range from the obvious, like industrial processes, to the more mundane, such as everyday household chores. One major source is tire wear. Every time a vehicle moves, its tires interact with the road surface, causing friction. As car tires rub against the road, they shed tiny particles, and a significant portion of these particles are plastic. These microplastics are then released into the environment, where they can be picked up by the wind. These particles can then become airborne and travel long distances, even reaching remote areas far from roads and cities. The wind acts as a carrier, dispersing these particles across vast regions, impacting ecosystems that are seemingly untouched by human activity. Another surprising source of airborne microplastics is our trash. Landfills, often located on the outskirts of urban areas, are hotspots for microplastic generation. When plastic waste isn't disposed of properly and ends up in landfills, it slowly breaks down into smaller and smaller pieces. This degradation process is influenced by various factors, including weather conditions and the type of plastic. This process is accelerated by sunlight and heat, eventually producing microplastics that can be swept up by the wind and carried into the atmosphere. The combination of physical breakdown and environmental exposure ensures that these particles are continuously generated and dispersed. Once in the air, these particles can travel vast distances, polluting ecosystems far from their origin. They can settle in water bodies, soil, and even enter the food chain, posing a threat to wildlife and human health. But it's not just tire wear and decomposing waste that contribute to the problem. Everyday activities and industrial processes also play a significant role. Microplastics are also released into the air during manufacturing processes that involve plastic, as well as everyday activities like washing synthetic clothes. Factories that produce plastic goods often emit tiny plastic particles as a byproduct. Every time you toss a fleece jacket or a pair of yoga pants into the washing machine, tiny plastic fibers are released from the fabric. These fibers are so small that they can easily escape through the wastewater system. These fibers, too small to be caught by most filters, are then discharged with the wastewater or become airborne as the clothes dry. This means that even our laundry routines contribute to the spread of microplastics in the environment. The widespread use of plastic in countless everyday products, coupled with inadequate waste management systems, has created a situation where microplastics are virtually unavoidable in our environment, including the air we breathe. From packaging materials to household items, plastic is an integral part of modern life, and its pervasive presence has far-reaching consequences. Understanding where these particles come from is the first step in addressing this growing environmental and public health challenge. By identifying the sources, we can develop strategies to mitigate their release and reduce their impact on our planet. The discovery of microplastics in human blood and tissue has raised concerns about their potential effects on our health, and one area of particular concern is reproductive health. While research is still ongoing, some studies suggest that exposure to microplastics could have negative impacts on both male and female fertility. In men, studies have shown that exposure to certain types of plastics can interfere with sperm production and quality. For example, bisphenol A or BPA, a chemical commonly used in plastic production, has been linked to lower sperm count and motility. While BPA is being phased out of some products, other chemicals used in plastics may have similar effects. Women are also at risk, as microplastics have been found in placental tissue, indicating that these particles can cross the placental barrier and potentially reach developing fetuses. The long-term consequences of this exposure are still unknown, but it's a worrying finding that warrants further investigation. Some studies suggest that exposure to microplastics could disrupt hormone levels, potentially affecting ovulation and overall reproductive health in women. The potential impact of microplastics on fertility is a serious concern. Given the ubiquitous nature of these particles and their presence in our air, water, and food, it's crucial that we continue to study their effects on reproductive health and take steps to minimize our exposure. Section 4. The Gut Check. Microplastics and your digestive health. As we learn more about the ways microplastics infiltrate our bodies, it's becoming increasingly clear that our digestive systems are on the front lines of exposure. These tiny particles, often less than 5 millimeters in size, are pervasive in our environment. They are found in the air we breathe, the water we drink, and the food we consume daily. These tiny particles enter our bodies not only through the air we breathe, but also through the food we eat and the water we drink. Microplastics have been detected in a wide range of food products, from seafood to fruits and vegetables, and even in bottled water. This widespread contamination means that avoiding microplastics entirely is nearly impossible. While research is still in its early stages, some studies suggest that microplastics could be wreaking havoc on our guts. Scientists are working tirelessly to understand the full extent of the impact these particles have on our digestive health. Early findings indicate that microplastics can cause physical damage to the intestinal lining, leading to inflammation and other health issues. One concern is that microplastics may disrupt the delicate balance of our gut microbiome, the trillions of bacteria that reside in our intestines and play a crucial role in digestion and overall health. The gut microbiome is essential for breaking down food, absorbing nutrients, and protecting against harmful pathogens. Disruption in this balance can have far-reaching consequences for our health. Some studies suggest that microplastics could promote the growth of harmful bacteria in the gut, potentially leading to inflammation and other digestive problems. Inflammation in the gut can manifest as symptoms like bloating, pain, and irregular bowel movements. Over time, chronic inflammation can contribute to more serious conditions such as inflammatory bowel disease, IBD, and other gastrointestinal disorders. Another concern is that microplastics could interfere with the absorption of nutrients in the digestive tract. The presence of these particles might hinder the gut's ability to effectively absorb essential vitamins and minerals, which are crucial for maintaining overall health and well-being. These tiny particles might bind to nutrients, making it more difficult for our bodies to absorb them effectively. This binding can prevent nutrients from being properly utilized by the body, leading to deficiencies even in individuals who consume a balanced and nutritious diet. This could potentially lead to nutrient deficiencies over time, even if someone is consuming a healthy diet. Nutrient deficiencies can have a range of negative effects on the body, including weakened immune function, reduced energy levels, and impaired cognitive function. While more research is needed to fully understand the long-term consequences of microplastic exposure on gut health, the early findings are concerning. Scientists are calling for more comprehensive studies to determine the extent of the impact and to develop strategies to mitigate these effects. Given the crucial role our gut plays in overall health and well-being, it's essential that we continue to investigate the potential impacts of these tiny particles on our digestive systems. By understanding the risks, we can take steps to protect our health and reduce our exposure to microplastics in our daily lives. Section 5. Can't catch your breath. Microplastics and respiratory problems. Breathing is something most of us take for granted, but for millions around the world, respiratory problems are a daily struggle. While factors like air pollution and smoking are well-known culprits, emerging research suggests that even the air itself might be harboring a hidden threat: microplastics. These tiny particles, small enough to be inhaled deep into our lungs, are raising concerns about their potential role in